Hi, I welcome you all to my course on AWS along with serverless framework. So in this particular tutorial, I'll teach you on what serverless framework is and how you can use serverless framework to connect with AWS and many of its services. So I'll be giving you live examples along with the code base, and if you have any issues, please do not hesitate to get in touch with me and I'll be glad to help. Thank you, and I hope you enjoy this course. Now, before we begin our course on serverless framework, let's discuss on what serverless is. So serverless computing is a cloud computing model in which the cloud providers allocate machine resources on demand and take care of servers on behalf of the customers. So when we think about serverless, we generally think about services like Lambda if you're working in AWS, or Function App if you're working in Azure, or Cloud Functions if you're working in GCP. But that's not true. You can also include tools like SQS, SNS if you're working in AWS, or other application integration tools if you're using the other cloud providers as well. So these gambit of services also come under serverless. And also so does the S3 bucket and all the other storage related capabilities that are provided by cloud providers. So serverless not only means compute like Lambda and functions, but it also includes integration tools and storages. So that's one thing you should keep in mind of when you're talking about serverless. So as long as the service allocates machine resources on demand and the servers are taken care of by the cloud providers themselves, then that particular service can be termed as serverless. So now let's talk about the features of serverless. The first feature of serverless that makes it very appealing is zero administration. So here, once you have your service set up, you do not have to worry about your server, whether it's working, whether it has been patched, etc., etc. All those administrative tasks are taken care of by the cloud providers themselves. So that's one very important and very key feature of serverless. So this is a very important feature of serverless. The lookup, the administration of the infrastructure is taken care of by the cloud providers themselves. The second key feature is auto scaling. So auto scaling makes it possible for you to ramp up your infrastructure as per needs. So as your application keeps growing in size, then serverless application will auto scale and it'll use extra resources or extra infrastructure to make sure that your application is running properly. The third important feature of serverless is pay as you use. So you only pay for the resources that you have used. So let's say that you have used your Lambda application for a particular period of time. So you only have to pay for that particular period of time and not more. So this makes it quite cost efficient as well. And the fourth most important feature of serverless is increased velocity. So now that because your application has zero administration and it scales seamlessly as per your needs, it's possible for you to develop an application in a shorter period of time than you would have had to if you were not using serverless. So these are some of the key features of serverless. So on this particular slide, I have pasted a link. You can go check out that link and see the need for serverless and see all the features that are available in serverless. So now that we know what serverless is, now let's look at some of the disadvantages of using serverless. Now these disadvantages are only applicable for the compute services that are currently available. So this includes services like Lambda, app functions, or the cloud functions that are available in GCP. So the most important disadvantage is performance. Then there are the resource limits, monitoring and debugging, and the vendor lock-in and security. Now I have marked them colored as red and yellow. Now the yellow ones are probably disadvantages that can probably be bettered later on. So monitoring and debugging tools currently are quite rudimentary in some of these services, but gradually they will get better. So now let's look at some of the more critical problems of using serverless. The most important problem is, again, like I said before, performance. And this is related to a concept called cold start. So now let's look at what cold start is. Now the most critical aspect of performance is a concept called cold start. So the cold start can be defined as the setup time that is required to get a serverless application up and running when it is invoked for the first time and within a definite period. Now, cold starts are something of an inherent problem that is applicable across all cloud platform providers. This includes AWS, Azure, and GCP. So now based on a few parameters, your cold start can increase or decrease. So the increase in cold start would inherently mean an increase in latency and a decrease in performance of your application. Now, the two most important factors are the code size and the language used. So the larger the code size of your application, the greater the cold start would be, and the lesser the performance or the latency of your application will increase. Now, similarly, another important factor to consider is what kind of language you are using, whether it's a compiled language or an interpreted language. So in the next slide, we will see the difference between using a compiled or an interpreted language. Now in AWS and Azure currently, there are ways to overcome cold start. AWS has a concept called provisioned concurrency, and in Azure you can use a premium plan and above to overcome cold start. However, these are expensive ways to overcome cold start, and it would cost you more to use these services. So now let's look at what cold start is in a more diagrammatic way. So the cold start is basically the loading of your code as a zip file, then the creation of a container, and then after that loading the runtime for your particular application to run. So these two combined together form the cold start. Now, as I said before, the larger your code size, the greater the cold start would be. And also another factor is whether you're using a compiled language or an interpreted language. So the compiled language would take more time to compile that particular code. Whereas if you're using an interpreted language, there is no concept of compilation of code. So that results in a lesser cold start if you're using an interpreted language. Underneath is a diagram to show you the difference between an interpreted language and a compiled language when it comes to the cold start execution time. So if you look at a code like Java, you can see that the cold start is initially around 300 millisecond, whereas if you're using a node based application, then it's around 3.5 to 3.75. Now there is a very good blog for this particular concept of cold start that I have linked in this particular slide. I will also mark this particular URL in the resources for this particular section. So please go through this and understand what the concept of cold start is, and this is a term that will come up across all platforms, and it is something that is not going to go away anytime soon. So now the other disadvantage of using a serverless application is that you have limited time and limited memory. That is because you wouldn't want your serverless application to be running forever. You would only want to run or execute small chunks of code for a limited period of time with a limited memory. Now, even though this is not a disadvantage, but this is something that you should be aware of. For example, at this moment, if you're using an AWS Lambda, your function cannot run for more than 15 minutes. Similarly, if you're using Azure, your function cannot run for more than 10 minutes. That is if you're using the consumption plan. These are different for the other plans, however. And similarly, if you're using GCP, the maximum that your code can run for is 9 minutes. And the same is the case with the memory as well. The maximum memory that AWS allocates for a particular Lambda function is 10 GB. And for Azure, it's 1.5, and for GCP, it's 4 GB. Now, these are limits that will keep changing. And if you look at this slide and if you see that the numbers are different, that's probably because those numbers have been changed. So I would imagine that these numbers would keep increasing. That is, the time limit would keep increasing, and so would the memory. So another disadvantage of using serverless is that you will have lost control over your hardware and the runtime. And what eventually happens is that you end up using other proprietary cloud specific tools that were making it difficult for you to move out of that particular ecosystem. So let's assume that you've created a Lambda application. Now you would want a trigger like an S3 bucket or an SQS or an SNS. So you would use that. You would also use other services like EC2, Aurora database, etc., to make a complete application out of your particular Lambda. So once you have done that, you've basically created a application which uses proprietary cloud specific tools for AWS. And once you've done that, it's next to impossible for you to change from AWS to, let's say, you want to migrate to GCP or Azure. So this is something that you have to be aware of. You should be aware of the fact that once you are stuck in AWS, then you're stuck in AWS forever, because of the fact that you would be using other proprietary cloud specific tools along with your Lambda. So that's again something of a disadvantage if you're using serverless. In this particular section, I will discuss with you what serverless framework is and how it makes it easy for you to create serverless applications using this particular framework. I will also discuss with you the advantages of using serverless over other infrastructure as a code platforms like Ansible and Terraform. So let's proceed and let's see how this works. Okay, so now that we know what serverless computing is, let's talk about a framework called serverless. Now, these are two different terms altogether. Serverless computing is a very general term, whereas serverless framework is basically a tool which can be used for building applications that are centered around Lambda. Now, Lambda, if you're using AWS, it could be something else if you're using some other cloud provider. For example, if you're using Azure, then it would be centered around app function, or if you're using GCP, it would be centered around cloud functions, the GCP cloud functions. So there are two important concepts that I would like you to know before we proceed. The first concept is called as the function. Now this function is basically the code that you would be executing in Lambda. And then there is the event which would trigger that particular code. So these two form the foundation of the serverless framework. And you should always keep in mind that for every serverless framework, there would be a function and then there would be an event to trigger that particular function. So you could consider serverless framework to be a specialized infrastructure as a code tool. Now, unlike other tools like Terraform or Ansible, or if you're using AWS, a tool like CloudFormation, the difference between those tools and the serverless framework is that you can use serverless framework just for creating Lambda-based serverless applications. You cannot use serverless framework for creating EC2 machines. It is specifically for building applications centered around Lambda. Now, if you glance through your right, you can see a set of events that can be used to trigger your Lambda function. Now, in AWS, there are quite a few substantial events that are available to you to trigger your Lambda function. So we will go one by one and check out the most important events that can be used to trigger your Lambda function. So now that you have a brief overview of what serverless framework is, the next question you would ask yourself is, why do you need to use serverless framework? You could achieve the same using other tools like Terraform, Ansible, or even CloudFormation. Well, the answer lies in the simplicity. So here to your left, you have a serverless application. Now, as mentioned earlier, it has a function and it has an event. So the function points to the code, the Lambda code, and the event points to an HTTP trigger. So what this does is, once you deploy this particular serverless application, it will create a Lambda called hello, and that particular Lambda will contain the code that you see in the bottom. And it will also create an API gateway that will be connected to that particular Lambda. So in the background, you can see that a lot of heavy lifting is done by the serverless framework itself. Now, if you were to achieve the same using CloudFormation, you would need to write at least 1,000 lines of code. So just a few lines of code in serverless corresponds to at least a few hundred lines of code in CloudFormation. But like I said before, this is only applicable if you're creating serverless applications and not for creating other infrastructure like EC2 machines, etc. So this is the basic advantage of using serverless framework. All the heavy lifting of creating Lambdas, the API gateways, creating roles for those Lambdas and API gateways, it's done by the serverless framework itself. All that you need to worry about is writing your application code and a few lines of configuration. So that's the most important reason as to why you should use serverless framework if you're creating serverless applications. So the final conclusion would be that if you're creating a serverless application, you should be using the serverless framework. And for everything else, you should be using CloudFormation or the native infrastructure as a code tool provided by AWS. Now let's look at the difference between creating your application in serverless and creating the same application in Terraform. Now, if you look at the size difference, you can see that creating an application of the same type in Terraform would require a lot more lines of code. So again, like we've discussed previously about CloudFormation, if you need to create serverless application, go for the serverless framework. And for everything else, you should be using Terraform. And the same is the case with Ansible as well. It's much more convenient and much more simpler to use serverless framework for creating serverless applications. So now, due to the popularity of the serverless framework, AWS has released its own CloudFormation templates called as SAM. Now, you could use SAM as a substitute for serverless, and they both would work absolutely fine. So, why would you want to choose serverless over SAM? Well, the most important reason would be serverless supports not just AWS, but you can use serverless to also create applications in Azure and GCP. And it also has the concept of plugins, which adds other functionalities to your serverless application. Now, like I said before, if you want to create a serverless application, you can absolutely go ahead and use SAM or serverless. Both would work perfectly fine. But if you have situations where you would be using multiple cloud vendors, then serverless would be a better option. So now the question arises as to the situations in which you should not use serverless. The first situation is if you're not creating a serverless application, then serverless framework is of no use to you. And the second most important thing to remember is that you should know a bit of CloudFormation if you need to be really good at serverless framework. Because ultimately what happens is if you deploy a serverless application, what eventually gets created is a CloudFormation stack. And if you have any issues and if you're not able to decipher how a CloudFormation stack works or looks like, then you might be in deep trouble. So you should always remember that if you're using serverless, then it is imperative that you have a bit of information or knowledge about CloudFormation. And you should only use serverless if you intend to create serverless applications. If you have situations where you need to create EC2 servers or VPCs, then you should use tools like CloudFormation or Terraform or Ansible. So before talking about the serverless framework, let me give you a brief overview about Lambda. Now, Lambda is a service provided by AWS, and Lambda is basically a serverless compute service that lets you run small snippets of code without having to provision or manage services. The good thing is you can run 1 million requests for free per month, and this is for an unlimited period of time. So even if you're short of money, you should try this out and it wouldn't cost you much. All that you need to do is just create an AWS account and start working on it. Some of the benefits of using Lambda is basically the same benefits that you would get running any serverless application or any serverless service. So that includes continuous scaling. So as more and more requests keep coming in, the scaling happens automatically. You don't need to manage any servers, and you only have to pay for what you have used, and the metering is done for each millisecond. And there is consistent performance at any scale. So even as you ramp up or as more users start using your Lambdas, the scaling wouldn't affect the performance of your Lambda. So let's have a brief overview of how Lambda looks like in the AWS console. Now you can go to your AWS console and you can either go to your services and click on Lambda, or you can just type Lambda here. You can just click on this and it opens a Lambda dashboard page. So here what you can do is you can actually create new Lambda functions. I already have a few already created. So creating a Lambda function is quite easy. So all that you need to do is just click on create function. And here you have the option of either creating a Lambda from scratch, using a blueprint of an already existing Lambda, creating Lambdas using container images, or using your serverless app repository to create your Lambda functions. So I'll be choosing the first one, author from scratch. And all that you need to give is you need to give a name for your particular Lambda. So I'll just call this as my first Lambda. And now here you can choose your runtime. You have a plethora of options here. You can either choose .NET, Java, Python, Ruby, or Node. So here you should consider that it has both interpreted as well as compiled languages. So the compiled languages will have more cold start delay than the interpreted ones. So you can just choose Node 14. So I'll let that remain. And here you need to choose the execution role. Now this is a very important concept and it's related to IAM. So here you can create a new role that will give this particular Lambda permission to upload logs into the CloudWatch logs. So here it will create a new Lambda, it will create a new role and assign it to this particular Lambda. So you either have an option of creating a new one or choosing an existing one. So here I'll create a new one and I'll let this remain as it is, and I'll click on create function. So once your Lambda has been created, you can just scroll down, and here you can see that there is a small snippet of code that's already created for you. So it's just a very basic node application that just returns a hello from Lambda back to the user. And let me just run this particular Lambda. So to do that, you can just click on test. And here you just need to give your input. You have to give a name for your input. So I'll just call this as my event. And I'll click on create. And if I click on test, it'll just return me back hello from Lambda. So this is a brief overview of how Lambda looks like. And the other important thing that you should remember is that this particular Lambda is currently not triggered by an HTTP or any other event. So this is currently a silo Lambda that can't be triggered by any other external source. And also this particular Lambda has got that role which we previously saw. So let me just show that role to you. You can go to configuration, you can go to permission, and here this is the name of that particular role that you created, and it has access to put logs into your CloudWatch logs. So this is a very brief overview of how Lambda works. It's a vast topic, and I have created a few YouTube videos regarding Lambda, and I will be putting those YouTube videos in the description or in the resource section below. So you can just go have a look at them and see and get a more detailed overview of how Lambda looks like or how Lambda behaves. Okay, so now that you know a bit about Lambda, let's install a serverless framework in our local machine. So to do that, you first need to install Node.js. So you can go to the Node.js website and install whether it's on Linux or whether it's on Windows. So I've already installed Node.js. This particular link I will be attaching in the resource section below. So you can just copy that and use that link to download Node. So once you've downloaded Node, the next thing you need to do is you need to install the serverless framework. So to do that, you just need to run the npm install command. So let's do that. So you can just do an npm install /g serverless to install serverless framework on your local. So once you've installed serverless, all that you need to do is just do a serverless /v to see whether it's been installed. So you can see that it has been installed. So let's proceed now and see how you can attach your serverless framework with your AWS account. Okay, so now that you've installed your serverless framework in your local, the next thing you would want to do is you need to connect it to your AWS account. So to do that, the first thing you need to do is you need to create a user with admin access. And after that, you need to get the secret and the access key for that particular user and use those to connect to your serverless framework. So let's do that. So let's go to our AWS console. You can go to IAM. To do that, you can just search for IAM and click on IAM. So the next thing you need to do is you need to create a user. Click on users, click on add user, and you can just create a user. So I'll just call this as serverless user. I'll give him both programmatic as well as management console. Though you don't need to give him the management, you just need the programmatic access, which will give that particular user the access key and the secret. So you can auto generate a password. You can click on next. And you can give him admin access. So I already have an admin group created. To click on this, and you can just click on next, review it, and click on create user. So here you'll have the secret, the access ID and the secret key. So what I'll do is I'll just download the CSV for this particular user. So if I open this, so if you open the Excel sheet, you'll see that you get both the secret access key and the key ID. So make sure to save this in a very safe place and don't let anybody else have access to these particular key and secret. Okay, so now that you've got your access key and your secret key, so the next thing you need to do is you need to configure your serverless using those keys. There are two ways to do it. The first way is using the AWS CLI. Now to install the AWS CLI is very straightforward. It's just a normal setup. The link on how you can install the serverless CLI I will give in the resource section below. So you can just browse through that link and see how you can install AWS CLI. So once you install your AWS CLI, you can open your command prompt and click on AWS. So you'll get a response like this. So if you get a response like this, that means you have your AWS CLI installed. So now let's configure our key and secret using AWS CLI. So to do that, you can just do an AWS configure. Click on enter. And here you need to give the access key. So this is the same access key that we generated in our previous slide. Again, you need to give the secret key. And then you can either give the region, or if you wish, you don't need to. And the output format is also not necessary. So the only thing you need to give is the access key and the secret access key. So once you've done this, you have your AWS configured with your serverless. Now let's look at the other way you can configure your serverless, that is without the AWS CLI. So without the AWS CLI, there are two ways you can install the access key to connect to your serverless framework. The first way is using the export command, and the second way is using the serverless configure credentials. So in both ways, you need to use the access key and the secret key. So in the first way, you can just do an export AWS access key ID and paste the key ID. And similarly, you can just paste the secret access key ID as well. And the second way is you need to use the serverless configure credentials. And here you just need to give the provider name and the key and the secret that you created in the previous slide. So these two would be the assignments that you would be doing. So please do connect with me if you're facing any issues using this, that is without the AWS CLI. It's very straightforward and you should have absolutely no issues. Okay, so now that you have your serverless framework installed in your local machine and you have configured AWS, the next thing we'll do is we'll create an application. So to do that, let's run the serverless command initially. So I'll just do a serverless. And here it gives you an option on which runtime you want to choose and how you want to trigger it. So let's start with the most basic Node.js starter. So you have the option of choosing other events as well, like the REST API, schedule tasks, SQS, worker, etc. So let's start with the most basic one, and I'll click on the first, that is the Node.js starter. Yes, I'll call this as the AWS Node project. Okay, it's already taken, so I'll just call this as AWS Node project 1. So the project has been successfully created, and it has also generated a folder called AWS Node Project 1. So I will not log in or deploy it right now. I'll do it later on. So before I proceed, I'll just show you how the project folder looks like. So to do that, I'll just open it using my VS Code. So here I've opened that particular folder using my Visual Studio Code. So you can use any editor of your choice. So I prefer using Visual Studio Code. You could also use Sublime. I will paste the link to Visual Studio Code in the resource description below. So the important files you need to consider is the serverless.yaml file. So the serverless.yaml file currently has just one function, and this function is just pointing to this code called handler.hello. So let me just open this particular handler.js. So this handler.js just has one particular function, and this returns a message back to the user, and the message is go serverless vs. Your function has executed successfully. So these are the two important files that you should always remember. There is the serverless.yaml file, and then there is the handler.js. Of course, I'll be explaining these files in more details in the coming lectures. So before I do that, I just wanted to show you how these two files look like. So the next thing we'll do is we'll just deploy this particular serverless.yaml file. To do that, you can just go to your terminal. I'll open a terminal. And because I have connected my AWS account to my serverless using the AWS configure, all that I need to do to deploy this function is just run the serverless deploy command. So here you can see that it has created a function called AWS Node Project 1 Dev Hello. So let's see in our AWS console whether there is a function by this name. So if there is, that means that particular function has been uploaded by serverless. So I'll go back to my console. I'll open my Lambda. And you can see that 40 seconds ago, there was a function called AWS Node Project 1 Dev Hello. So this is how you deploy your functions using serverless. So this was a very brief tutorial. I will go more in depth in the coming lectures. So this is just to show you how you can use serverless initially for the first time. One more thing to remember is that you can run your functions directly using serverless. So you don't need to go to your console in AWS to run this function. So you can just use the serverless invoke function /f and point it to the function name, which is hello, and return back the logs, that is using the /l. Here you can see that it has returned a successful status code 200, as well as the body which says that go serverless, your function has executed so successfully. So this is one way you can actually invoke your function. You don't need to go to your AWS console to invoke the function. You can do it locally using serverless as well. So one more time, the command is serverless invoke /f and the name of the command. The name of the function followed by /l, which will return you back all the other logs as well. So if you don't use /l, it will just return back the status code and the body, and it will not return back to you the logs. So that is how you invoke your function using serverless. In this section, I'll explain to you what happens when a serverless deploy command is invoked. And also finally, after that, I'll also explain to you how you can delete all your serverless resources using the serverless delete command. So now this is a very important chapter. And here in this particular chapter, I'll discuss what actually happens when you create a serverless application, all the tasks that happen in the background, and how CloudFormation is closely linked with serverless. So let's create a new application and let's decipher all that goes underneath when you create a new application and deploy it into AWS. So this time around, we'll be creating a Node.js with REST API. So what this does is it will create Lambda as well as an API gateway, which will be used to trigger that particular Lambda. So let's just click on the second option. So let's go into our VS Code and let's see how this particular code looks like. So the two files that are the most important are the handler.js file and the serverless.yaml file. So let's open the serverless.yaml file. So here you see that there is a new event that gets created, which wasn't there in the previous example because the previous example did not have a trigger to this particular code which resides in the Lambda. So this particular trigger is the HTTP trigger and it has a path and a method. So with this, you can decipher that when you deploy this particular serverless.yaml file, what will happen is it'll create an endpoint. It'll create an endpoint with a /path and it'll be an HTTP get method and it'll trigger this particular Lambda. So let's try to run this particular Lambda and let's see what happens. So before we do that, you'll see that there are just these two files present and there's nothing else except for the readme file and the gitignore file. So let's deploy this file and let's see what happens. So again, I'll go back to my terminal and I'll do a serverless deploy. So you can see that a new folder got created called as the .serverless folder. And it has two very important files. There is the CloudFormation create file and then there is the CloudFormation update file. So we'll be discussing these two files in this particular chapter and what those two files actually mean. And let's look at the handler.js file as well. So again, this is just a Lambda which will return a function successfully executed back to the user. So here you can see that there was an endpoint that got created along with the function. So the previous example that I showed you just had the function. So this particular serverless.yaml also deployed an endpoint. So let's just go to our browser and let's see what happens if we run this particular endpoint. So you can see that there was a response that gets returned back to the user. So what has actually happened in the background? So when you ran the serverless.deploy function, what has actually happened is it has created two stack files, CloudFormation stack files. Now CloudFormation, like I said before, is the native infrastructure as a code tool provided by AWS, and it is the tool that is used to actually create the infrastructure. So that's how serverless is different from other tools like Ansible and Terraform. Ansible and Terraform have their own capacity to create infrastructure, whereas serverless is very dependent on CloudFormation to actually create the infrastructure. So serverless as such is just converting all the code, all the serverless.yaml configuration into CloudFormation, and then it is that CloudFormation that is actually creating the infrastructure in AWS. So that's one very important thing that you should remember, that the infrastructure is at the end of the day created by CloudFormation, and serverless just has the task of creating or compiling the serverless.yaml and converting it into a corresponding CloudFormation template. So there are two CloudFormation template stacks that are created. So the first is the create stack, and once the create has run, it just updates that same stack again. So the CloudFormation create stack, it creates a bucket and it provides a policy for that particular bucket. And apart from that, it just uploads that particular handler.js code into that particular bucket. So once that happens, the next update code, what it does is it creates all the infrastructure that we need. It creates the Lambda, it creates the API gateway, it creates the API, the Lambda role, and the Lambda code is basically accessed by the bucket that was created by the create stack. So that's a gist of what actually happens when you do a when you do a serverless deploy. So let's look at it in a more diagrammatic way. So whenever you do a serverless deploy, it creates a serverless folder, and within that it creates two CloudFormation files. It first creates a stack using the create CloudFormation file and then updates the same stack using the update. The create stack, or should I say the create JSON file, initially creates a S3 bucket, and within that S3 bucket it uploads the code, the Lambda code. And after it has done that, then it runs an update on that same stack. And once this updates JSON file runs, it creates all the other necessary infrastructure needed to run your piece of code. So for example, it creates your Lambda, it creates your API gateway, and it creates all the roles and all the other necessary resources. So let's go and look at the stack and let's see what are all the resources that gets created. So to do that, you can go back to your console. Go to CloudFormation. Here you can see that this is the particular stack that was created by serverless. So I'll just open this. And here you can see all the events and all the resources, the outputs and the parameters. So the most important thing you should see is the resource. So if you click on this, you'll see all the resources that have been created by this particular stack. So here you can see the Lambda that got created, the API gateway, and all the logs and all the other execution permissions. So you can just go through this and just open all the relevant ones. For example, if you want to see the Lambda, you can just open this. And this was the Lambda that was created by serverless. Again, let's go back and let's open the API gateway. So this is the API gateway that got created. So this is a easy and a convenient way to see all the resources that have got created. So finally, to conclude, what happens when you do a serverless deploy is it creates a CloudFormation file which is used to create a stack, and this stack contains all the resources that you need, including the API gateway and the Lambda. Okay, so now that you know what serverless deploy does, let's remove all the resources that we've created. To do that, you can just run the serverless remove command. So let's see what happens when we run the serverless remove command. So what this does is it basically deletes the stack which was created in CloudFormation. So once this serverless remove is done, we can go check what has happened to that particular stack that was created when we did a serverless deploy. Okay, it says that the stack has been deleted. So let's go back to our console. So you can see that that particular stack has been deleted. So if I just click on the deleted stack, you can see that this particular stack was just deleted. So that's what happens when you do a serverless delete. What it does is basically deletes the stack in CloudFormation, and along with that, it deletes all the resources that was created by that stack, which includes all the lambdas and the API gateways. Okay, so in our previous lecture, we were able to create a serverless application and connect it with a API gateway using the REST API. So it created two files, the serverless.yaml file and the handler.js file. The handler.js file contains the code that would be inherited by the Lambda. So now let's look at the serverless.yaml file. Let's dissect the serverless.yaml file and let's see what it is made up of. Now, if you look at the serverless.yaml file, it has certain keys. So let's discuss all these keys one by one. So the first key is called as a service. So this basically is a identifier for this particular serverless project. So here the key has a value of test, and test is basically to identify this particular serverless project. And then comes the provider. The provider has certain attributes associated with it based on what cloud provider you're using. So if you're using a AWS cloud provider, then the key value pairs associated with it would be different as compared to if you're using another provider, let's say like Azure or GCP. Now, I will discuss all the provider key value pairs in the next lecture. So we can just leave it at that currently. And then comes the functions. This function is basically where you define the pointer to the code as well as the events that will trigger that particular Lambda. And then finally, we have the resource. The resource lets you add AWS CloudFormation templates to your serverless.yaml file. So this is something that we will discuss later on while we are creating functions and events. So finally, there are four basic attributes to your serverless.yaml file: the service, the provider, function, and resource. So let's discuss what a provider is in our next chapter. So now let's talk a bit about the provider section of the serverless.yaml file. Now the provider is different for different cloud vendors, and this particular provider is specific just for AWS. There is a link at the bottom, and that particular link will tell you all the parameters that can be defined for the AWS provider. The most important ones are the Lambda defaults, the IAM defaults, and the VPC defaults. So the Lambda defaults can be used to reconfigure the timeout, the memory, the region, the stack name, etc. So there would be a default associated. Now, if you want to change the default to something else, then you would do it in the provider. I'll be demonstrating the use of IAM defaults and VPC defaults later on while I give you examples of functions and events. So in the meantime, I have a few assignments set up for you. So what you need to do is you need to create a HTTP API based serverless application like I had done previously. And then later in the serverless.yaml file, you need to update the Lambda defaults. So the Lambda default is currently set to 6 seconds. So you need to change it to 30 seconds. And you need to change the memory from 512, which is the default, to let's say 3 GB. So please go ahead and do that. And if you have any issues with that, please get in touch with me and I'll be glad to help. Now, in our previous lecture, we had seen the anatomy of a serverless.yaml file. Now, each serverless.yaml file can have multiple events and functions associated with them. And you can just connect each function with its own code. So here in this particular example, you can see that function 1, function 2, all of them are pointing to the same handler.js code. Now, what is the problem with this approach? So the problem with this approach is that the CloudFormation stack has a limit of 500 resource. So you can't create more than 500 resource in your CloudFormation stack. And for each event and function, there are about 10 resources that are created. So what happens eventually is you run out of resource, and if you create, let's say, around 60 to 70 functions and triggers, then eventually the CloudFormation stack will fail, stating that it doesn't have capacity to store any more resources. So this is something that's very important, and you should always be aware of this fact. So to overcome this, what you can do is you can create a microservice for each particular serverless.yaml file. So here in this example, you've seen that I've created multiple services. For example, the user service, the account service, the customer service, and the sales service. And they all correspond to different CloudFormation stacks. So in this way, you can not only segregate your code, but you can also overcome that 500 resource limitation that CloudFormation has. So let's see how you can do this using serverless. So the first thing I'll do is I'll create a service. So I've created a folder called my project, and within this I'll run this serverless command. And here again, I'll take the REST API number 2. And now here I'll call my project as my user service project. So I'll call this as user service. So I will not register, neither will I deploy. And now I'll create another project called account service. So let me just run the serverless again. And here again, I'll choose number 2. And here I'll just call this as account service. Okay, so it has to be a slash. I'll again do a no. Now, if I do an ls, or should I say if I do a dir, you can see that there are 2 folders created. Now, each of them correspond to one particular service, and each of them would contain its own serverless file, and you can deploy each one of them individually. File. So if I go to user service, you can see that there is a serverless.yaml file created. So this is how you'll create a microservice based application using serverless. Okay, so now let's talk about the meat and potatoes of this particular course. So we'll be discussing the events that trigger the Lambda function. So there are multiple events, but there are a few which are actually important. And those include API gateways, S3, DynamoDB, Schedule, SNS, and SQS. So in the upcoming chapters, not only will I discuss on how these events can be connected to functions, but I'll also give live scenarios and demos on how you can actually implement applications using serverless. The code base is available. Please do not hesitate to use them. And if you have any doubts, please do not hesitate to get in touch with me as well. And I hope you enjoy the following lessons. So let's start by creating our first event. So again, this would be the most basic use case that you would see. So this is again an HTTP trigger that will call the Lambda. So if you look at the code, then the events will have a /HTTP. So whenever you see /HTTP as an event, that means you are going to have a particular Lambda connected to an API gateway. So let's proceed and let's see how we can create this. So we had already created this before using the serverless command, but this time around I'll use another command to create the same. So there's another command called serverless create. So this particular link I will provide in the description below. So I'll just copy this and I'll paste it in my VS Code. So I've opened my terminal. It's a brand new project, so let me just paste this. So what it does is it will create a service in the my service. So it will create a new folder called my service, and in that it will create the serverless.yaml file and all the other artifacts. So let me see if the boilerplate is created. So let me just go to my service. Okay. CD my service. And if I do an ls, you can see that there is the serverless.yaml. So let me just open the serverless.yaml file. So let me open my serverless.yaml file. So the advantage of using serverless create to create your service is that if you look at the serverless.yaml file, you will get all the events that can possibly be used by serverless. So it includes again like the HTTP event, also the other events are also included. So you can just uncomment this particular event that you want and you can run it. So this is quite convenient if you do not want to search for all the events. So what I'll do in this particular scenario is I just want to uncomment this particular part. So I'll just go to edit and I'll toggle line. So here what will happen is this particular event will create a path called /user/create and it will be a get method. So let's also look at the code. So again, I would assume that the handler.js would be a very basic hello world. So let's go back to the serverless.yaml. So you can see everything else is commented. So there is the provider which has AWS. Again, the runtime would be Node.js. And then there's the Lambda hashing version. So here you can actually change the other parameters like we had in the previous section, like for example, the memory, the timeout, etc. But we wouldn't be changing any of those. And apart from that, there is the function, the handler. The handler points to the handler.hello code, which resides in the handler.js. And then there is the event, the /http. I guess it has changed. It used to be HTTP. I think they've changed it to HTTP API. So let's just run this code. So again, to run, you just need to do a serverless deploy. Okay, I think there is a bad indentation. So what you need to do is you also need to uncomment the event. So let me just run this again. I have to save this. So again, it's creating the serverless folder and it's creating the stack here. So let's just wait for this to finish. Okay, so once it has finished, you can see that the endpoint has a /user/create and it is a get method. So let's just copy this URL and let's see what it returns. You can see that it has returned that your function has successfully executed, as well as the event. So if you go back to the code, the handler.js, you can see that it's also outputting out the event. So that's the first and the most basic example of events. So this is again like the HTTP event, which connects your Lambda to the API gateway. So the exercise that you need to do is you need to go check the stack, check what API gateway got created, and check the Lambdas that got created and see all the settings there. Now here for my second example, I will take another extremely common use case. So in this particular example, what you have is a Lambda, and this Lambda wants to access a private resource in a VPC, and it wants to return it back to the user via the API gateway. So this is a very common use case, and you would generally use it to connect to a database. So you have a database which is connected which does not have any public IP address, but is connected via the private IP address. So the Lambda would fetch information from the database and it will return it back to the user. So this is an extremely common use case. Again, the event remains the same. Now the only thing that changes is in the provider, you also need to specify the VPC. You need to uncomment the VPC and you need to specify the subnet and the security group for this particular VPC so that the Lambda is able to access this particular VPC. So you have the option of choosing more than a couple of subnets and more than a couple of security group IDs. So let's go ahead and let's see how this is done. So for this example, I have created a EC2 machine. And this EC2 machine is running an Apache web server. So what I want is when I connect to the API gateway via the Lambda should return back the Apache web page back to the user via the API gateway. So this is the instance, and I'll be connecting using the private IP. So I'll be using this particular IP address to connect to this particular instance. So I'll just copy this. I already have a piece of code to fetch that particular information. So let me open my handler.js. So this is a very basic HTTP request that is being sent to this particular web server again. So I'll just copy paste this IP address, and so once the Lambda is triggered via the API gateway, this particular Lambda will fetch the information from this particular server and then return it back to the API gateway. So this is a very common use case again. So let me go back to my serverless.yaml file. So here I've uncommented the VPC and I have added 2 subnets and added 2 security group IDs. So to get the security group IDs and the subnets, you can just go to your console, and the first thing you need to make sure is which particular VPC this EC2 belongs to. So this EC2 belongs to this particular VPC. So let me just open this VPC. So what I need to do is I need to get 2 subnet IDs from this particular VPC. So I'll just copy this and I'll go to my subnets, and you can see there are quite a few subnets available. So I've just taken the first 2 subnets, and again you can go to the security groups as well, and you can choose any of the security groups. So I've just chosen the first 2 security group and I have pasted it over here. So that's the only thing you need to do. You just need to paste the security group and the subnet IDs for that particular VPC, and the event remains the same. It's again an HTTP event. So let me just deploy this particular function. So I'll go to my terminal and I'll do a serverless deploy. Okay, so now that the stack has finished running, so let's just copy this particular URL and let me just paste it. So hopefully it should just give me back the Apache homepage. So you can see that it has returned back the Apache homepage. So again, this was using the private IP address of the web server. So this is one way in which you can connect to any private resource using Lambda connected to an API gateway. So I hope this was a useful lesson for you. I will be pasting the code and the other relevant information in the resource section below. Also, one more important thing for you to check is you can actually go to your Lambda. You can click the Lambda that you've just created here, and here under the configuration, you can click on VPC and you can see the subnets and the security groups have come here. So this is one way in which you can verify whether your serverless.yaml has properly executed and your subnets have properly populated in this particular Lambda. So this is a useful check to see whether everything is correct and everything has been properly set up. So let's continue with the same YAML file. So in our previous section, while talking about the anatomy of a serverless.yaml file, I had spoken about a section called resource. So let's see what a resource section is. So in the resource section, what you can actually do is you can actually add snippets of CloudFormation templates. So let's just uncomment this particular. So it generally lies at the end of the serverless.yaml file. So if I uncomment this, what will happen is it will independently also create a bucket by this particular name. So let's try to see whether this works. So here I'll create a bucket. So hopefully when I run this particular piece of code, it should also create a bucket by this particular name. So this is what resource does. So you can use resource to create other independent infrastructure if you like. So there would be various use cases in which this could be actually quite useful. So let's deploy this and let's see what happens. Okay, the stack has finished running. So what I'll do now is I'll just go to my S3. And I will check whether that particular bucket is created. So you can see that it just got created. So this is one way in which you can actually create bucket using serverless. Now, if you go back to the serverless.yaml file, you can see that this is of type S3 bucket. So if you want to create resources of other types, you basically just need to go through the documentation. Now, for example, if you want to create an EC2 bucket, you can always go to Google and type EC2 CloudFormation, and the first result that you would get would be the one that you need. So you could go to the examples and you can just copy this snippet of code. Of course, it has to be in YAML. You can just copy this snippet of code and see whether it actually works. So that's probably an assignment for you guys. So you can just copy this and see if an EC2 machine has got created. And so in that way, you can actually use your serverless.yaml to create EC2 machines, even though it's not recommended. But if in case you have scenarios where you are desperate to create an instance or are desperate to create infrastructure which otherwise cannot be, then this is always a last resort. So in our previous section, we talked about HTTP events. So in this particular section, we will talk about S3 events. So in an S3 event, what happens is whenever a file is uploaded onto an S3 bucket, then a particular Lambda can be triggered. So in this particular example, what happens is whenever an object is added into this particular bucket, then the function will be triggered. That is, the Lambda will be triggered. Here, another thing that I would like you to know is that there is another key called custom, and in this custom you can store variables. So for example, I have stored a variable called bucket, and this is basically the name of the bucket. Now to access this variable, you can just do a $self and just give the name of that particular variable. So here in this case, it would be custom.bucket. So let's see if this example, so let's have a look at this particular example and let's see how we can use this. So here again, I have my same piece of code as I had shown you previously. Here I've used the custom, and within this custom, I've added a variable called bucket. And this bucket is basically what's going to trigger this particular Lambda. So another important thing in serverless is that even if this bucket does not exist, it will be created for you. So for example, let's create a bucket by the name of very lazy coders trigger.s3. So let's see if this particular bucket exists. So let me just copy this. I will go to my S3 console. So you can see that this particular bucket is already existing. So let me just delete this bucket. So I will first empty the contents of this bucket. And now I'll delete this particular bucket. Okay, so now that the bucket has been deleted, let's just deploy this function. So everything else remains the same. So again, the trigger here, the event here is not HTTP, but it's S3. And it's pointing to the new bucket that will be created. So again, it's $self, and this is the name of the variable custom.bucket. Another important thing to know is, even though it's not very important, but it could be useful for you, this particular custom variable can be also used in your CloudFormation stack. So at the end, let's say you want to output the value of that particular resource. So you can use this particular serverless.yaml variable in your resource as well. So this is something that can be useful for certain use cases. So let me just run this particular. Okay, so now that the stack has finished running, let's go and check whether our S3 bucket is created. So let me just refresh this again. So here you can see that it has again created that S3 bucket. So let's try to trigger this particular Lambda. So I'll just open this. I'll upload a file. I'll just upload any random file. And let me upload this. Okay, now let's go back to our Lambda. So this was that Lambda that got created. So if I click on monitor, okay, the first thing is you can see that there is an S3 connection to this particular Lambda. So if I click on monitor, if I go to view logs in CloudWatch, so you can see that there is an instance in the log stream. So that means that this particular Lambda was triggered when I tried to upload that particular object into this bucket. So this is how you can use an S3 bucket to trigger your Lambda. So I hope this was useful for you. And before going, I would also like to see the stack and see whether the output has that same variable that was created in the serverless.yaml file. So let me go to my CloudFormation. So that's the reason why you have to be quite competent with CloudFormation if you need to be good with serverless. So you need to have a basic understanding of CloudFormation. So again, let me go to my so this was the most recent, and if I click on output, you can see that this particular value was actually created in the serverless.yaml file, and it has got carry forwarded or transferred to the CloudFormation stack. So in our previous section, we had seen that you can upload a particular object into an S3 bucket, and that can cause a trigger to a particular Lambda function. So let's suppose that particular Lambda wants to read that particular object that was uploaded. So let's see how that would work. So currently I have written a piece of code using the S3 library to read that particular data. So the event parameter would contain all the necessary information. So it would contain the bucket and the key. So that's because this particular Lambda is triggered by the S3 and by the uploading of the object itself. So that's the reason why the event would contain both the bucket and the key for that particular object. So using these values, we can use the S3 library to fetch data for that particular object. So it's a very straightforward code. This code snippet I will just paste in the description or the resource below so you can have access to it. So once we've done that and once we've uploaded the object, if you go check the logs, you'll see that there is access denied. That is because this particular Lambda does not have access to read that particular S3 object. So ideally, to do that, what you would do is you would give access or permissions to that particular role to read that particular object. So we can do the same in the serverless file itself. So within the particular provider, you can give an IAM role statement, and within that you can allow to read that particular S3 object for that particular bucket. So the bucket here would be very lazy coders trigger.s3. So let's add this particular statement to the serverless file and let's try to upload an object and let's see whether it's able to read after that. And I'll go to my serverless.yaml file, and here what I'll do is, so I've already created this particular IAM role statement. So what I'll do is I'll just uncomment this. And again, I will just deploy this particular serverless function. Now, if you want to verify, you can always go back to the serverless update file and see whether that particular IAM policy is updated here. So So you can see that there's an allow of get object for this particular S3 bucket. So this is always one easy way to verify whether your changes have been updated in the CloudFormation stack. Okay, so this has updated the stack. So what I'll do now is I will go to my S3 bucket and I'll upload a file. So I'll click on upload, click on add file. I'll upload the CSS file. So if I click on this and I click on open, and then let me just upload this. So again, I'll go back to my Lambda. So you can see that a new log got created. So if I open this, and if I open this, you can see that that particular CSS file can be seen here. So now this particular Lambda has permissions to access that particular object, or should I say the bucket. Now if I go back to my Lambda and if I click on configuration and if I click on permission, so if I see the rule now, if I click on this particular role and if I see the permissions for this role, it should have that particular permissions that makes it possible for that particular Lambda to access the S3 bucket. So you can see that this particular permission was added to this particular role. So that's the reason why it was able to access that particular S3 object. So I hope this was a useful example for you, and I hope to see you soon. Another very important event that you can use with your serverless.yaml file is called the schedule. So what this particular event does is that it causes the Lambda to trigger based on the schedule that you have given. So in this particular example, what I've done is I have created a schedule that will trigger every 10 minutes. And once the trigger happens, what it does is it will read an API, and the response of that API, it will forward to an email. So let's see how this particular service works. So for this service, I have used the simple email service that is provided by AWS. So let's look at the serverless.yaml file first. So the event again here is you just need to uncomment out the schedule, and you can just give a rate based on whatever time you like. So here I've given a rate of 60 minutes. So let me just change this to 10 minutes. So what will happen now is that particular Lambda will be triggered after every 10 minutes. And another important thing that I have done is I've also enabled a IAM role statement that will give permission for that Lambda to access simple email service. So now let's look at the handler. The handler has two basic components. The first component is it will get an API. So this is a API that returns back the current value of a Bitcoin. So if I just open this API, so it will return the value for this particular Bitcoin. So once I get this information, what I'll do is I will send this information to an email ID. So to do that, you need to configure your simple email service. So let's see how that works. I go to my AWS console, I type SES. So this is a free service, so this wouldn't cost you. What I mean is it's a free service till a limit. So if you exceed it, then it will probably cost you. So if you're just doing it for a few email IDs, it wouldn't cost you. Again, here you go to the email addresses. So here you can verify a new email address. So here you can just specify your email address, and you can go to that email address and verify that particular email address. So for example, let me just try to verify this particular email address. So as you can see, currently it's in a failed state. So the first thing I'll do is I'll just remove this. I'll click on it, and here I'll just paste my email ID. and I'll click on verify this email address. So now what has happened is an email has been sent to this particular email address. So I just need to verify it there. So let me just go to my email ID. Here you can see that I've received an email ID. So what I need to do is I just need to click on this URL to verify it. Okay, so it has been verified. Now again, if I go back to my simple email service, and if I refresh this particular page, you can see that it has been verified. So what I'll do now is I'll just copy this email ID and I'll go back to my Lambda function. And once I receive this particular value from this particular API, I will send it to this particular email ID. So for this, again, I'm using the, okay, let me just copy this. So I'll just paste this email ID. So here I'm using the library that is provided by AWS. So I'll be using the simple email service library and I'll be sending this email ID. Again, this code I will paste in the resource or the description below. So again, let me just reiterate what I have said. This particular Lambda will get information about the current value of Bitcoin from this API. And once I get the response, I will send it to this particular email ID. This particular email ID has been verified by SES, that is the simple email service. So let me just deploy this particular serverless file. Let me save this. So now that my service has been deployed, let's go and check our email. So here you can see that I have received a few test mails from my simple email service. So here it returns me back the value that I received from the API. So that means this particular Lambda is basically triggering the API and sending the value or the response back to this email ID. So let's go and check the email ID. Let's go and check the Lambda once. So if you go back to that Lambda, you can see that this particular Lambda is triggered by an event bridge. And if you open this event bridge, you can see that the scheduled expression is 10 minutes. So whenever you include a scheduler in your serverless.yaml file, what happens is that an event bridge is created and that same expression that was there in the serverless.yaml file is updated in the event bridge. So I hope this was a useful lecture and I hope you've learned a bit. Thank you. So in this particular section, we'll be discussing on how we can use streams as an input or as a trigger to a Lambda function. So this is another very basic use case that you guys would always deal with. So in this particular scenario, let's assume that you have a database of users, and whenever a user is inserted into the database, you want to send a verification email to that particular user. So in this particular example, what I'll do is I'll create a DynamoDB table called user, and in that one of the fields would be the email ID. So once the user is created in the database, it would trigger a Lambda event, and then that particular Lambda event would call a verification email service. So again, in this particular section, I'll be using the SES to verify the email. It's up to you. You can use your own custom service or any other third-party service to do the same. So let me reiterate what I'm going to do. I'm going to create a database called users, and in that, whenever there is an insert, that particular entry for that particular user would be streamed to that Lambda. Then that Lambda would pass the email ID from that stream, and then it will pass it to a SES verify email service, and then that will send a validation email to that particular user. So let's see how this is done. So the first thing I'll do is I'll create a Dynamo table called user, and I need to create a primary key. So I'll just create a primary key called user ID, and let me just create this table. Once you've created this particular table, what we can do is we can add items. So let me create an item. And in this, I'll just make the user ID as 001. And I'll add just two columns. I'll just add the name and the email ID. let me just, and here I'll just put in a valid email ID, and let me save this. So you can see that I was able to create, or should I say insert values into this particular table. So the next thing we'll do is we'll go to our Lambda and we'll create a function to fetch the value from this particular stream, and then to process it, and then to verify that particular email ID. But before that, the first thing we need to do is we need to create a stream. So what we can do is we either have the option of creating a Kinesis data stream or a DynamoDB data stream. You would need to pay for Kinesis, but for DynamoDB, at least the first few, I think, GBs of data is free. So you can always go ahead and do DynamoDB if you're concerned with the cost. So let me just create a managed. So I'll keep both the new and the old ID. So let me enable this. So it creates a stream ID. So you can copy the stream ID and you can go to your serverless file. And here in the events, so there is an option called stream. So here you can just paste that particular stream ID. Apart from that, again, because I'm using the simple email service, I am also going to create an IAM role statement that would allow all actions on the SES service. So let's go back to the handler and let's see what happens here. So in this particular handler.js, the event object would contain the email ID. So to get the email ID, you need to pass through this particular event and get this particular value. Of course, I'll again paste this code in the description or in the resource below, so you can always have access to it. So once you get the email ID, you just need to use this SES service that is provided by AWS, and you just need to verify email. You just need to call the verify email address function, and that's about it. So again, let me reiterate what I'm going to do. I have created the stream from DynamoDB, and then I'm going to pass this stream ID to my event here. So once this particular stream has been triggered, what will happen is in this particular event object, you can fetch the email ID, and then that email ID can be sent to the SES verify email address, and that would send the email ID to this particular email which you want verified. So let's deploy this particular function. Again, let's run the server, let's deploy. Okay, so now that the serverless has been deployed, let's create another item in this DynamoDB table. So let me create an item. Again, I'll just call this 002, and I'll just append it with, call this name, and I'll just append the email ID as well. So it's email. So let me save this. So hopefully this should trigger that particular Lambda, and that particular Lambda should, from the event object, get this particular email ID, and then it should call the function that would verify this particular email ID. So let me just save this. Again, let me go and check my email ID. So you can see that I've just received a verification email ID. So I can just click on this. Okay, so now let's go back to our Lambda. So this was the function that I created. So you can see that it's being triggered by a DynamoDB stream. So this is a very fine example on how you can use DynamoDB to trigger a Lambda event, and the Lambda can do such kind of activities like it could probably validate the data or verify whether an email ID is correct or not. So I hope this was a useful lecture for you, and I'll hope to see you soon. Another very important event that you can connect your Lambda to is called the CloudWatch event. So for example, in this particular diagram, you can see that whenever an EC2 machine starts running, at that moment, it can send a trigger to your particular Lambda, and then that Lambda, for example, could send an email or could send a notification or could do some other task. So let's see how this works. So the easiest way to find your CloudWatch event is to go to your Cloud Console. And in this, you can open your CloudWatch, and within the CloudWatch, there is an Events tab. You can open this. So in this, you can click on Get Started. And here you can find all the patterns that you could use in your serverless.yaml file. So in our example, what we'll do is we'll create an event whenever there is an EC2 machine that starts running, and that particular event will trigger that Lambda. So for that, you can go to your event pattern and you can search for EC2. And the event type would be the instance state change notification. So whenever there is a change in the state of that particular EC2, then that particular event will be triggered. So do you want it for any state or do you want it for a specific state? So I will choose a specific state. So I'll choose the state as running. So whenever the event turns to running, then this particular event will be triggered. And you also have the option of choosing for any particular instance or a specific instance. So I'll choose it for any instance, and it displays a pattern underneath. So you could use this particular pattern while you're creating your serverless.yaml file. So let's go to our code. So in this code, so all that you need to do is you need to give the source, the detail type, and the detail state. So this would change based on what particular source it is. So you can always refer back to the CloudWatch events to change the state and all the other details based on the values you get on in this particular screen. So again, let me just state that it's going to be an EC2 machine whenever there is an EC2 instance change with notification, and whenever the state changes to running, it will trigger this particular Lambda. And I've left this Lambda as it is. So if you want to do an assignment, you could instead just create an SES service and send an email to a particular email address. So that would be a good assignment for you guys to do. So again, I'll go back to my serverless and I'll just show this to you once more. So again, it's a CloudWatch event, and the event would be anytime an EC2 machine has an instant state change notification to running, then this particular Lambda will be triggered. So let's try to deploy this particular serverless file. So again, let's do a serverless deploy. Once. Okay, so the application has finished running. So what I will do is I will go to my EC2 console, and there is an instance which is in the stopped state. So I'll just click on this and I will start this particular instance. So once this instance goes to the running state, it should hopefully trigger that particular Lambda. Okay, it's in the running state now. Let's go and check our Lambda. So I'll open my Lambda. So this was the instance that I created. This was a function that I created. I'll go to monitor and I'll check view logs in CloudWatch. And here you can see that there is a log stream that is currently available. So this particular log stream was created when that particular EC2 went to the running state. So that is a way in which you can use your CloudWatch event and integrate it with your Lambda. So again, let's go and check if the trigger has been properly created as well. So I'll go back to my Lambda and you can see that there is an event bridge CloudWatch event that is available. So this is how you would connect your CloudWatch event to your Lambda using serverless. Another important event that you can have for your serverless.yaml is called the SNS. So let's have a very basic example of this. So we have an event which is triggered by this SNS topic called my topic. Now this particular my topic hasn't been created. So when you do a serverless deploy, this particular topic gets created. So everything else remains the same. There's just this particular SNS. And in the handler.js, what I've done, the only thing I've done is I've just displayed the event. So let's run this very basic SNS trigger and let's see how it works. Okay, so the Lambda has been created. So let's check our console. So if I go to my SNS, let me check if there is a topic called my topic that got created. So if you go to the dashboard, you can see that there is a topic called my topic that got created. So let's just add or should I say publish a message to this particular topic. If you go down, you can see that there is a subscription, and this particular subscription is that particular Lambda. So whenever I deliver a particular message, or should I say whenever I publish a message, then that message would be delivered to that Lambda. So I'll just send a message called test, and let me publish this. And if I go down, let me just open that particular Lambda. So if I just open this, so the first thing we'll check is whether it's being triggered by an SNS. So if you look at this function overview, you can see that this particular function can be triggered by an SNS. So let's just open this, and you can see that the name of the SNS is my topic. The next thing we'll do is we'll go to the monitor, we'll go to view logs in CloudWatch. And you can see that the log stream has been created. So if you were to just look at the log stream, you can see that there is a record that is being sent. Now, if you were to decipher this SNS, you would see that there's a test message within this particular object. So that's probably something that you can do as an assignment. You can just decipher this, or should I say, you can just stringify this object and see what the message is. So this is a very brief lecture, and I hope you've understood how using serverless you can connect your SNS, or should I say how you can trigger your SNS, trigger your Lambda using an SNS. So in our previous example, we had seen that using an SNS, you can trigger a Lambda. This particular example is going to be a little different. So in this particular example, we'll have an API gateway that will trigger the Lambda, and this particular Lambda will have a code that will trigger the SNS, and this SNS will send a mail to a particular email ID that we will configure. So in our previous example, because the event was SNS, therefore the topic got automatically created, but here we just have an HTTP as an event. So that will not create the topic. So for that, what we need to do is we need to go to the resource and we need to create the topic manually here. So here again, we'll just call the CloudFormation template to create the topic. And then within that topic, we'll also create a subscription. So this will be an email subscription. And then this particular subscription would be linked to this particular topic. So let's see how this works. So again, I go back to my code base. So this is the serverless.yaml file. Let me show you the serverless.yaml file. So this particular serverless file, because it's going to trigger an SNS. So for this particular example, I need the Lambda to access SNS. So for that reason, I've given permissions for this particular Lambda to access the SNS service. And apart from that, I just have the API gateway. So this is an HTTP request. So that will create an API gateway that will be connected to this particular code. And then apart from that, the very important thing we need to consider is that the resource section would have snippets to create a topic, and this particular topic would also have a subscription associated with it, and this subscription would be of type email, and here you just need to specify the email ID. So let me just specify a email ID. So let's go back to the code base and let's see what happens there. So the code base is very straightforward. I am calling the AWS library, and this particular library, I will just call the aws.sns service, and this SNS service will just publish this particular message text. So again, this is a very basic SNS functionality that is provided by the library, and this particular SNS will trigger the topic that would send the subscription to the email. So let's deploy this particular serverless function. Okay, the serverless function has been deployed. So the first thing we'll do is we'll check whether the SNS topic has been created. So let's go back to our SNS. So let me just refresh this particular page. So you can see that my topic has got created. So if you click on this, you'll see that there is an email ID and this is in pending status. So what I need to do is I need to approve, going to this email ID, I need to approve this particular subscription. So let me just do that. So as you can see that I have received a notification from AWS. So let me just confirm the subscription. And if I go back to my SNS, let me just refresh this particular page. So you can see that this has been confirmed. So now what I'll do is I will just call the endpoint. So let me just go back to my terminal. And let me just call this particular function. So when I call this particular function, this particular text would be sent to that email ID. So let me just paste this. So you can see that I have got a message saying that this particular function is executed, and I've also returned back the message ID for that particular topic. So if I go back to my email ID, so you can see that I have received this particular text message. So this is the same message that was there in that piece of code. So you can send any text message that you like, or you can actually send the message from the endpoint itself and pass it on to the email ID. So this is a way that you can utilize your HTTP, your CloudFormation resource, and your SNS to create applications like this. So I hope this was a useful lecture, and I hope to see you. So for our final event, we'll talk about SQS. So SQS is a simple queuing system that can be used to decouple two applications. So you have an SQS that acts as a bridge to communicate between two applications. So let's say you have service 1 and service 2, and if they want to communicate with each other, then you can use a service like SQS to do the same. Now in serverless, the only difference between using SQS and the other services like SNS and S3 is that in SQS, you have to also create the queue in the resource section. So for example, if you want to trigger this particular Lambda with, let's assume a queue, now this particular queue has to be also created in the serverless file. So for example, I'm trying to trigger this particular Lambda using Q1. So you also have to create the Q1 in this particular serverless file. So this is something that you can try as an assignment. So if you do not provide this particular resource and if you try to run this particular deployment, then this particular deployment will fail, and will fail stating that this particular queue is currently not present. So to overcome that, you have to make sure that this particular queue is also added. So now let's look at a very common use case that is seen across multiple applications. So here you see that there is an image upload, and this particular image upload will call an SNS topic. And this particular SNS topic is subscribed to multiple queues. And these queues can call independent lambdas or EC2 machines. So this is a very common use case, and you will certainly come across such kind of applications where both SNS and SQS are combined. So let's see how we can use this and create such an application in our serverless.yaml file. So again, let's go back to the serverless.yaml file. Now here is where all the action takes place. So if you look at the provider, the first thing I have done is I've provided both SQS and SNS access to this particular Lambda. And this particular Lambda will be triggered by an HTTP endpoint. So again, if you go back and correlate to that particular architecture, so this image upload can happen through an HTTP event, and this particular HTTP event can trigger an SNS. So within this handler.hello, what we will do is we will trigger an SNS, and that particular SNS will be subscribed to multiple queues, and these queues will call other independent lambdas here. So okay, so this is the first microservice that I have, and this particular microservice will call this particular handler or this particular piece of code, and this particular piece of code would be triggered by one queue, Q1. Similarly, I have another microservice called microservice 2. This will be triggered by Q2. Okay, so now we come to the resource part. Now here is where the interesting bit takes place. So this particular resource, the first thing it does is it has to create both these queues because like I said in my previous lecture, the queues are not created even if you have an event, if you have an SQS event trigger here. So you have to create Q1 and Q2. So that's what I have done here. I've created Q1 and Q2. Now also, because there is no direct SNS trigger, I also need to create my SNS. So here I've created an SNS called my topic. And then further after that, I have to subscribe both my queues, that is Q1 and Q2, to this particular topic. So for that, I have used the AWS SNS subscription template. And this particular template will just, so in this particular template, we just have to get the ARN number for my Q1. So this is basically the fetch queue. This is basically the name of the fetch queue that I have created. Similarly, I'll do the same for Q2 as well. So here I have subscription for my Q2. So here I need to give the ARN. So if you have any doubts about the syntax, you can always go and Google. So for example, you can just Google for SNS subscription and you will get the syntax. So let me just show how that works. So you can either copy this, or you can just go to Google and just say CloudFormation and just type SNS subscription. And it'll return, the first return would always be the one that you would need. So here you can always go check the example and see whether you have all the proper parameters set. So, okay, so now that we have subscribed both our queues to the SNS, the other thing we need to do is we also need to set a policy to our queue. So currently the policy that I have set is very broad, and this is not something that you should be setting in production. So what policy I have set is that any particular principal can have access to this particular SQS and this particular resource within that SQS. So basically my Q1 can be accessed by anybody. And similarly the same for my SQS, my Q2 as well. I've given a very broad access. So as an assignment, you can actually make sure that you just give the appropriate action, and for just the appropriate principal. You shouldn't be giving the principal a star. You should be just giving it to the individual or the resource that needs access to this particular queue. So let's try to run this particular serverless deploy. So what should happen is when I trigger the HTTP, it should trigger the SNS, and that particular SNS should trigger the queue, which will trigger the microservice 1 and microservice 2 Lambda. So the handler.js is very similar to the SNS code that I had previously shown. It just returns a message text to this particular SNS. So message text is the text that will be sent to this particular SNS topic, and this SNS topic, because it's being subscribed by those queues, will get the particular message, and that particular message will be sent to these microservice lambdas that I have written. Now these microservice lambdas have basically nothing. It is just console.log the event. So let's just wait for this particular stack to finish. Okay, the stack has finished running. So let's first check if all our resources are created properly. So let's go and check the SNS. So let's go to SNS, simple notification service. So there is my topic, and if I click on my topic, you can see that it's subscribed by these two queues. Okay, so this particular part is properly set. Now let's go back to our SQS and let's see if those two queues have been created. Okay, you can see that there is Q1 and Q2. So again, you can see the subscription here, and let's just check the Lambda trigger. So you can see that this particular SQS is being triggers this particular Lambda. So everything is fine. So all that we need to do is we need to trigger the HTTP endpoint. That particular HTTP endpoint will send that message to that particular SNS topic, and that SNS topic will eventually, because it's been subscribed by Q1 and Q2, will send a message to these particular Lambda functions that we created, that is microservice 1 and microservice 2. So let's go ahead and let's trigger that particular Lambda. So this is the HTTP endpoint. I'll just copy this and I'll paste it. Okay, so the next thing we need to do is, okay, let's see the message. The message that we should get should be, I'll go back to my handler.js. It should be this particular message that should be received by the microservice 1 Lambda. So I go back to my functions. Okay, you can see that there is microservice 1 and microservice 2. So I'll just open this microservice 1. And okay, so you can see that it's being triggered by the SQS. So if I go to monitor, if I go to view logs, so you can see a log stream entry. That means it has been triggered. So let's open this log stream. And if you were to see the record, so you can see that the body is message text. So this is basically the message text that was triggered by the SNS. So similarly, this particular text can be triggered by the HTTP endpoint, or should I say this particular message or any other message can be sent by the HTTP endpoint as well. And that can be propagated through into this particular microservice. So I hope this was a very useful section for you, because this particular architecture is very common. This particular architecture is very, very common, and it's very important, and it's very important to know that such kind of architectures can also be set using just your serverless framework.